Hi, so today we're going to be talking about section 1.3 in your textbook, algebraic expressions and models. So we're starting to really get into our algebra. And so let's do what I like to do at the beginning of our lessons. Let's talk about the definitions that we're going to be working with in this section and continually actually throughout the course. The first term is the word coefficient. The coefficient is just the numerical factor of a term. That's the definition. But if you just look at an expression with me like, I don't know, 2x, okay, the coefficient is 2. So 2 is the coefficient. And I'll put co. Okay. All right, term. Each expression within an equation. So if I give you an equation or something like this, I don't know, 2x squared minus 5x plus 3. Well, 2x squared is a term, negative 5x is a term, and 3 is a term. So we would say that this expression has 3 terms. Okay, another word I'm going to use a lot is going to be the word constant. And we talked about constant in an earlier unit, but a constant term is a term with no variables. So in the example up here, that's the constant. That 3 is a constant because it has no variables with it. A constant is something that just can't change. It's going to be 3 no matter what. No matter what x is, that 3 is going to remain the same. All right, so now that we got the vocab out of the way, let's get to business. So today we're going to be talking about powers, order of operations, like terms. So let's just review evaluating a power. There's a couple of things that you learned in algebra that we just need to make sure you fully understand. If I take negative 3 within parentheses and I raise it to the 4 power, that means negative 3 times negative 3 times negative 3 times negative 3, 4 times. And because the whole quantity is being raised to the 4, that means that whole quantity of negative 3 is being multiplied 4 times. Anytime we multiply a negative an even number of times, then it's going to turn into a positive because a negative times a negative is a positive times a negative then would yield a negative, and then a negative times a negative gives me a positive. So I know that this number is going to be positive. So I then do 3 times 3, which is 9, 9 times 3, which is 27, and 27 times 3, which gives me 81. So this would be a positive. All right, but isn't B exactly the same thing? Well, it's actually not, okay? So what you have to notice is that this negative 3 isn't in parentheses. So really what this means is negative 1 times 3 to the 4th. Because there's no parentheses, this hidden negative 1 is kind of hanging out there. That negative's kind of hanging out there. And the 3 is only being raised to the 4 power, not the negative 3. So this would actually give me a negative 81. We're going to talk about this a lot this year because it's a common mistake we make, and we just want to make sure we understand it clearly. All right, writing 6 to the 3rd power. So 6 is what we call the base, and we would raise it to the 3rd power. So we would say either 6 to the 3, 6 to the 3rd power, or 6 cubed. All right, moving on. Hopefully I'm not going too fast for you. In Algebra 1, I'm guessing that your teacher taught you about order of operations using the term PEMDAS, because lots of teachers like to use PEMDAS, and I even used to like to use PEMDAS. But as I've gotten older and more experienced, I've realized that I really prefer GEMDAS when we follow order operations. PEMDAS means parentheses, exponents, multiplication and division together, and then addition and subtracted together from left to right. The problem is that P messes kids up because it's not just parentheses. It's actually grouping symbols, okay? So G stands for grouping symbols, and there's some grouping symbols now that you're in Algebra 2 that you really kind of have to feel comfortable with. Brackets. Those aren't parentheses. I mean, parentheses, yes, are grouping symbols. Brackets are grouping symbols. Fraction bar. That fraction bar is a grouping symbol. So you're going to want to do anything like above the fraction bar, below the fraction bar first. Absolute value I like to think about as a grouping symbol, meaning you got to do everything in the absolute value bars. You can't distribute things through it first. So absolute value bars that look like that. And even square roots. So that's why I prefer GEMDAS. So when we talk about proper order of operations, I'm going to say GEMDAS. So grouping symbols, then exponents, multiplication together done from left to right, whichever one comes first, and then addition and subtraction from left to right. All right, so let's go and try a couple problems based on what we just reviewed. Negative 2 to the 6th power. All right. Well, we got to remember negative 2 to the 6th. So it's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. That's a really nice number for us to know. So I know that 2 to the 6th is 64, but is this negative doing anything to it? Remember, we talked about that negative. He's hanging out front because there's no parentheses, so my answer would be negative 64. All right, let's look at this next one. Order of operations says that I have to do everything in the grouping symbols first. And I tend to do that and evaluate that exponent. I might do that at the same time. So 5 squared gives me 25 minus 6. Now, here's the interesting thing, is a lot of kids may want to subtract those numbers, but you can't, because the order of operations tells me that I've got to do that 2 and that negative 1 to the 4 power first. So 2 plus a negative 1 means 2 minus 1. So I have 25 minus 6 times 1 to the 4 power. 1 to the 4 power is just 1. So then I get 25 minus 6 times 1, which is 25 minus 6, and it works out to be 19. Okay? All right, so that's a little bit about what we're going to be working on in class tomorrow, but let's keep moving. All right, evaluating an expression. So an example when I'm asking you to evaluate is basically I give you an expression, negative 3x squared minus 5x plus 2, and I say evaluate it when x equals negative 2. That just means let x be negative 2. That means just substitute negative 2 in for x everywhere in the equation. One thing, though, that I'm pretty strict about is when you plug a value in, like negative 2, into any equation for x, I want to see you put it in parentheses. So, for example, negative 3 times negative 2 to the 2 power, notice my parentheses, times 5 to the negative 2. So if you plug it in, you put it in parentheses. Plug it in, put it in parentheses. And that will help us not forget, different things that come up when there's negatives. All right, so now we've got to follow proper order of operations. So I'm going to do the exponents first. So that gives me negative 3, negative 2 quantity squared. I've got parentheses being squared. That's going to become a positive 4 minus 5 minus 2 plus 7. Okay, so then I'm going to do the multiplication. Negative 3 times 4 gives me negative 12. Negative 5 times negative 2 gives me positive 10 plus 7. And now I can do the addition and subtraction from left to right. So negative 12 plus 10 gives me negative 2. Negative 2 plus 7 gives me 5. Okay, now remember, if I'm ever going too fast, just pause, go back, and rewatch. All right, so why don't you try? When we're evaluating, being very careful. You've got to be careful because I'm not always just going to give you one variable. I could give you 1, I could give you 2. This time I gave you 2, but I could give you 3, I could give you 4. It still just means the same thing. When you plug it in, put it in parentheses. So I still do it all the time. And there's my parentheses, okay? All right, so why is that important to me? Well, because I see, again, a negative being squared, but if the parentheses weren't there, you might not square it. You might think it's still negative. So I've got 1/2 plus negative 1/2 squared is 1/4. So I get a common denominator, which gives me 2/4 plus 1/4, which is 3/4. All right, hopefully you're doing well with us so far. Let's keep moving. Oh, my favorite, simplifying by combining like terms. What does like terms mean? Like terms basically just means the same variable, or like terms are, the same variable raised to the same exponent. The same variable raised to the same exponent. So for example, I've got an x and I've got an x. X squared and x are not like terms, okay? They're not like terms because x squared is raised to the 2 exponent, whereas x is raised to the 1 exponent. So they're not like terms, so therefore you cannot combine them. All right, so let's practice. Let's try this. Well, the first thing that I notice is I'm going to have to use some order of operations here. I've got a 6 being multiplied to an expression, so I'm going to use that property that we talked about the other day, the distributive property. So I'm going to get 6x minus 6y. I've got a negative 5 being multiplied to x minus y, so I'm going to distribute a negative 5, so I'm going to get negative 5x plus 5y. Okay, in this case, seeing the like terms is actually pretty easy. I see a 6x and a negative 5x. Those are like terms. I can combine them, so that would give me 6x minus 5x, which is 1x. When I have done that part, I actually cross them out so I don't get confused. And then I've got a negative 6y and a positive 5y. Those are like terms. They are the same variable raised to the same exponent. So I add them just like I add numbers. So negative 6 plus 5 would give me a negative 1y, which is negative y. All right, so that one wasn't too bad. But what about if I throw in bigger variables? So in the next expression, hopefully it says negative 4j squared minus 7k plus 5k plus j squared. So if it doesn't say 5k, change it to a 5k. All right, well, I clearly look and I see that negative 4j squared and j squared are like terms because they're the same variable raised to the same exponent. So I can combine them. Remember, I never change the variable. It's going to stay j squared. I'm just going to deal with the numbers, the coefficients that are in front. There's that word coefficient. So I have a negative 4 plus a 1, which gives me negative 3. All right, then I see that I've got a negative 7k and a positive 5k. Those are like terms. So I'm going to add the numbers and keep the variable, and that's going to give me minus 2k. And I've combined the like terms. All right, so what I want you to do is I want you to do the try nows. I want you to do number 1 and number 2, and then I'm going to check them with you in class tomorrow, okay? So I want you to do number 1 and then number 2, combine the like terms to make sure that you know what you're doing, and then we can talk about it in class tomorrow. All right. Last thing I want to talk about, and we're going to really go into detail tomorrow, so don't worry if you don't remember this. We're going to talk about evaluating in real life using a model, meaning using a word problem and writing an expression for ourselves. So a couple things that I like to talk about before we write any word problem is asking yourself what type of question do you think you're dealing with, okay? Is it linear? And you may recall that linear equations are in the form y equals mx plus b. Right now, we are going to see a lot of linear equations. So what I like to teach kids is that m, that slope, is actually the changing value, or the average rate of change. And the b, the y-intercept, is the starting value. And we're going to talk about that one in a little bit, okay? I like to make sure that you set your variables. So set variables. You're usually, when you're setting your variables, you're getting the unknown from the question being asked. And again, I'm going to go over that, but I want you to have your little cheat sheet for yourself. Okay, another thing that you always want to look for is, do you need a common formula? Do you need a common formula? And the last thing that we're gonna ask ourselves, and common formula, I mean area equals length times width, the area of a rectangle, or perimeter, or distance equals rate times time. All right, and then the last thing I always ask myself is, do I need an expression or equation? And usually they're gonna tell you either write an expression or solve, and if you're solving, you need an equation. All right, so let's look at just a basic example. You want to buy either an iTunes gift card or a picture frame as a gift for 10 people. iTunes gift cards is $15 and the frame costs $12. Write an algebraic expression for the total amount you could spend, and let's assume you'll buy both. Okay, so in my mind, I know that I'm going to be buying two different things, so there's two unknowns, okay? So I let X equal the iTunes gift card, or the number of iTunes gift cards, and I'm going to let Y equal the number of picture frames. Okay, so we know that X and Y together, if it's the number of items, that we have 10 people, that means we're going to buy 10. So X plus Y equals 10. All right, the iTunes gift cards is $15 and the frames cost $12. So, and so let's think about that. We've got 15 times X as part of my expression for the total amount. But what about the $12? What are we going to multiply? We're just going to say 12 times Y? Well, then we're going to have two variables. And right now, honestly, what I'd like to see is that we can see that we can make y, we can actually call it 10 minus x if we solve for y. So I'm going to write that as 10 minus x. And that's going to give me the total amount that I'm going to spend. Hopefully, we're going to talk about this piece a little bit more in class tomorrow. But, all right, so I would simplify it. So I'm going to get 15x plus 120 minus 12x. And then I'm going to combine the like terms, so I will get, what is that, 3x plus 120. So 3x plus 120 is the amount that I could spend to buy these gifts for my friends. All right, so we're going to stop there today, and we're going to just go over all this tomorrow. And I know I went really fast today, so don't worry. Tomorrow we're going to spend a couple of days on all of this, so and you'll get all your questions answered. If at any point you feel like you need to rewatch the video, go ahead and do so. All right, see you later.